So this is last talk for this sambaXP from me, I promise. And this is a variant of a talk I gave earlier this year at FOSDEM about our, I would say, journey, because this spans quite a few years now, to make authentication in Linux passwordless and user-friendly. When, as usual, you choose friends first, but then you need to be friendly with them. And this talk is kind of an overview of what we had over actually 40 years in this area. Where we are, specifically in FreeIPA, but what I am saying, keep in mind, maybe 90% of it applies to Samba AD with MIT backend. And where we will be in near future, in Fedora specifically. So in past, we had interesting kind of story. We had certain assumptions for operating like in server and client environment. Two big assumptions were there. First, we had compatible authentication mechanisms. So you cannot authenticate to a server if both server and client are not supported. But we also relied on a transferable state of authentication, which means that you have some mechanism to say, okay, I authenticated to this system, and if I want to move laterally to a different system, then I need somehow to transfer this fact that I already authenticated, right? So typically on a desktop, you log in, and with your password, you log in into the system, but also this password is passed through the PAM stack to other parts and unlocks secrets in your session. Okay, this is an example of transferred kind of knowledge about authentication. Very simple one within the single application stack or on a single machine. Now, if you want to move around, you need to somehow re-authenticate every time, but you have to do this with some mechanism. And we consume resources, like in this case, access to the secrets manager, to the password stored in the secrets manager, based on the fact that we unlocked something. There are always issues with specific applications. These days, for example, browsers know about and have their own password managers. They do not have really good integration into system-wide password manager, but somehow we deal with that, right? For lateral moving, the natural thing over past 40 years, let's say, we have Kerberos. And okay, 30 years in reality, but we get there because it's all these ideas, they float around at that point. And Kerberos actually solves three different problems. The first one, because authentication is decoupled from actual use, how you authenticate is largely independent from how you consume resulting ticket granting ticket, which makes an interesting point, which is been made over and over again over years, that mechanisms to authenticate these principles change. And for example, originally we had this password authentication with encrypted timestamp. Then we decided, okay, this is not secure enough, we need to use some other methods. Then governments decided they want to use strong authentication with smart cards. So smart card integration effectively replaces your password with encrypted timestamp. Then around 10 years ago, so we decided that, okay, even for password, we want to have some mechanism that is more secure and strong than this encrypted timestamp. We invented SPAKE, pre-authentication mechanism, which uses modern crypto to do this. SPAKE, as it defined, it has capability to pass multi-factor details inside it, even though it's not implemented. So we are going kind of modernizing pre-authentication thing, but we keep all the other stuff the same. Everything keeps working, regardless how you obtained the initial token. And the interesting part is that, yes, it becomes complex enough. This is from RHEL documentation, a very helpful kind of diagram how it works in a Active Directory with forest from FreeIPA, bunch of kind of flows that happen there. But I was talking about this in 2016 at FOSDEM and show it, hey, we can do what is called enterprise desktop. So basically a GNOME desktop with login into the system with smart card or a password gives you Kerberos ticket, which you then can consume in your browser. So if your browser visits a website that supports your Kerberos authentication, you get single sign-on. And this was eventually integrated in all browsers. So we worked with Firefox, with Mozilla, getting it there. Then we worked with Google to get this into the Chrome, made some painful things to let those developers to understand semantics and understand that, for example, you really shouldn't give access to these single sign-on when you're in private mode or something like that. You should really make what the user needs to do. They did not understand, and this was like several times a big problem. But at the same time, we extended Open Connect implementation to authenticate over Kerberos, for example, and added support for KDC proxy, which allows you to authenticate to using Kerberos, obtain initial ticket while you still don't have access, direct access to the Kerberos server, to Kerberos KDC, which is nowadays used, for example, by Fedora. Fedora exposes HTTPS proxy to the KDC, but not the KDC itself, which means that you can authenticate first and then use that ticket to authenticate to your VPN, which is a normal thing actually with Windows. It's hidden behind a nice facade, but is used there. And I think in December 2021, Microsoft actually added similar support to Azure AD. So Azure AD enrolled Windows systems can obtain Kerberos tickets against Azure AD, and then they can be consumed by Azure AD file server, for example. Transparently, the same way as it's consumed in Active Directory, using the same KDC proxy technology. So this is 2016, so it already exists, it works with the things, but what happened over these, how many, 7 years, is that the reality changed. The biggest change in this reality was driven obviously by mobile and software as a service, cloud services, and so on. The people basically stopped caring that their laptop or their phone or something enrolled properly into the directory services. What they cared about is that there is a single sign-on into cloud applications. And that's a huge difference. the device that you bring to work with these does not matter. The device is just a vessel to deliver an engine, which browser is, to render something. So we effectively switch it or trade it for whatever convenience of using phones to do our job. We traded that infrastructural security for admins, traded for convenience of users. These users don't care that this laptop is enrolled or not enrolled somewhere. What they care about is that they can reach their application. And it's a nightmare for admins. It's a good thing for users, probably. And even better thing for those cloud providers who now have a way to charge everyone for every access and so on. Okay, but the most important part that I want to make is that, yeah, browser became really a new mainframe. It's a window into a world that runs somewhere else. And the way to authorize this access, OAuth2 became the king there. People quickly started to forget how all of these things work, how Kerberos works, what is the enrolling your machine into the Active Directory and so on. We are now at the point where a generation that was born in this century is graduating from universities without really a good knowledge or understanding of these technologies. And consumer-wise, they are more familiar with Android and iOS rather than with Active Directory or hard way of installing all of it on Linux. Maybe with Linux, they are also more like a user focused than knowing how all this stuff works. So we effectively have this bring your own authentication that puts it in. Jeremy, do we have a mic? Can we get a mic for Jeremy?
I'm sorry. Alexander, you mentioned that people graduating in this century don't understand the old technologies. Do you really think they understand OAuth2 as well?
They don't.
Because I have studied and tried to read the OAuth2 specs and work out how it works. I don't get it.
But you're old.
Maybe I'm old and stupid, but I just cannot figure out how that thing works.
Welcome to the club.
Yeah,
What
it's
they
awful.
have, which we don't have ourselves, is a helpful set of libraries written by others and a lot of courses and documentation around this as application developers.
Sure, but they just consume in the libraries. They don't understand exactly how the
They do
underlying
consume
technology
libraries, and
works.
that's enough to create fast integrated applications into something.
I guess.
It's much harder for them to start doing anything with Active Directory or Linux PAM stack and so on themselves. This is the important part, because if you're getting into, let's say, big enterprises, the direction of IT and of transformation in the big enterprises is quite clear. Dump down individual pieces, connect them by well-defined interfaces, connect access to those through OAuth interfaces. That's where it is going. For the application developers, this is there. Nothing else matters, and relegated to be as a printers now. So you don't know how printer works. You complain when the printer fails, and then you summit some guys like Jeremy or Andreas to fix these problems.
It's not that people are getting dumber, and it's
Yeah,
not that
they're
they're dumbing
not.
down. It's
They
that
focus
it's
on a different
yeah,
thing.
yeah.
That's the
it's,
point.
it's not just that they're focusing on a different problem. It's that if you want people to use a system like Kerberos, you have to make it accessible, usable, and well documented. And it is none of those things. And so if you're a website developer and you want to add Kerberos authentication, you may as well go outside, get a pair of pliers, and pull out your teeth, because that's going to be less painful.
Yeah.
And that's simply it, is that OAuth2 is easy from the point of an integrator, easy from the point of an administrator. Why would they bother with Kerberos? It is not about one being technically better or not. It's about focusing on accessibility.
And I would say even more than that. As an application developer, I wouldn't care about Kerberos. I will relegate this task to OAuth identity provider developer. That's what they have to do. And that's what the model that is being promoted among application developers. Everything goes on to web, and this is where OAuth is the key. Okay, so IDP, identity provider, that provides this OAuth authorization framework, is inside it, there is an implementation of a login method, and there's a variety of login methods, and one of them can be Kerberos, and that's a normal thing, right? So if we look into all of this from the perspective how it was 7 years ago, we had captive portals, the big thing in 2016. Every single hotel ran their own captive portals showing adverts, collecting information about you. So for enterprise desktop, this was a nightmare, because before you log in into your system, you have to acquire consent from the Wi-Fi point. And you cannot log in your system because you want to be on the network for that. In this year, what we have is about the same. So if we want to log in into OAuth, if we want to use OAuth2 authorization mechanism to log in into our system, we need to be able to communicate over a network. And the most natural way of communicating there is by using a browser, because all of these providers, they drive you through nice screens that allow you to choose your identity and then maybe associated sub-identities. So for example, if you want to log in into Azure AD, you can log in there using your Google identity or GitHub identity, and for doing that you will be transferred to a Google website or GitHub website where you will complete something else, and Google, for example, can have you federated for your local organizational portal as well. So there's like several steps of going until you reach the point that actually logs you in and then authorizes that login to be promoted back to the place where you tried to access. So all of these roughly the same. We still don't have a browser running before login for performing captive portal thingy or Auth2 authorization. Stories are the same. It's of course the same problem of how we deal with the insecure content presented by the browser, how we deal with the browser overall. I've got stories told to me by Windows developers that when they were designing this on OAuth2 login into Azure AD and other things, they face a similar problem. So if you run embedded browser that only shows you the Azure AD login page, they are test subjects, they press buttons like links for help in that page, because that's the part of the general page. So you press help and get to some other place where you quickly get to the Google search engine, where you quickly type YouTube, get YouTube link, and you watch YouTube before logging in your Windows machine. And these kind of things happen everywhere. You cannot really curate a list of URIs that you access, and it's what it was called the bullet and the yeah, and the protection in the warfare. We have the same with the security of this access. But okay, we need to do something about this, and I will come to this later. If we have a different system where the browser is, hey, we have this different system, for example, we can use that other system to handle our login and authorization. Maybe we don't need to run the browser directly on the system. And this is supported use case actually for the OAuth2. This is called device code authorization flow. It's used by all of these dumb devices like TV, the smart TVs. They are dumb devices because they don't have a keyboard to type your password, or you don't want them to type your password, but you want them to connect to your YouTube account so that you can watch some stuff. We can use the same mechanism, and I think some time ago Microsoft actually used this in the Linux implementation of logging into Azure VMs. They used this, but then decided to avoid it. Well, in FreeIPA we implemented it last year, so we have this support to log in using the OAuth2. Not just Azure ID, it works for everything except GitLab. GitLab does not support device code authorization flow. It's a problem of the Ruby OAuth, or not OAuth, the authorization framework that they use there. It simply does not implement it. But I have a demo how it works, which utilizes Keycloak, open source identity provider, which also provides OAuth2 and some other mechanisms. So here I'm logging in into Keycloak. I have only password, and I will associate some FIDO2 token with this user. Register it. This is just a normal Firefox browser. The demo was created for FOSDEM, so you can see FOSDEM WebAuthn key name. Okay, I registered this token with me, and I now can use this token instead of password to log in into Keycloak. This is not logging in into any Linux machine yet, it's just browser. Now I'm trying to SSH into the machine that is connected to this Keycloak, and I'm using device code authorization flow to do that. So this is the other machine's browser. In this case, it's my laptop. Okay, to log in, I just use the token and then confirm, authorize access to my data. And when I logged in, IPA issued a Kerberos ticket for it. So now this Kerberos ticket can be used for any other Kerberos activity. Jeremy wants to ask.
So if you could go back just to the demo you did, sorry. I see what you did there, right? You do realize that's completely and utterly unusable by normal people, right?
Yes.
Yeah, I mean, I've had to try and talk my wife through setting up something similar account. As soon as you get the login screen where you type in a username and there's no password and you have to click on try another way or whatever, that's it, it's gone. Nobody can use it. It's
I will come to that
unusable later. UI. Sorry.
Yeah.
And then the authorization, grant these roles, it's like, what does that even mean?
Don't spoil.
Sorry. I'm sorry.
It's late.
I'm so sorry. It's just, it's a beautiful demo, Alexander, but you and I can use it.
Yep.
Not, sorry.
Yes. So indeed, this is one of the problems. And as I said, the browser is what people use, and if we don't have a browser in the front, we have to deal with all of this. So you can use this mechanism to log in into your GDM in your thing. But what you will see in GDM is an input prompt that is inadequate to put this string of text that says, hey, visit this URL at all. And we are working on that. I will get to that. I just wanted to point that this is how it's implemented. It combines a pre-authentication method for MIT Kerberos and a backend implementation in FreeIPA, which is running behind MIT KDC to do all of this authentication. The mechanism, how it's done, is extensible, and we extended it with another method, which I will show shortly, and it's also transferable. So the same code of the backend can be plugged into Samba AD, and you will get this working. Again, whether you want to do this or not, it depends on what clients you serve, and I will get to that also later. Now, with this integration, actually, as you saw, we get also for free integration with the WebAuthn tokens, which is, well, the thing people think will be our future for passwordless authentication. Because OAuth identity providers might already support using FIDO tokens, and indeed, this is what my Keycloak demo showed. I had this. It's not the default configuration, but you can adjust and have the FIDO2 integrated there. And they may allow already login with WebAuthn. This is unusable, as Jeremy said, for general public, and we need to improve on this. And that's the whole point of all of these exercises, to find out what to improve and convince upstreams to work together. This is already in Fedora since last year. So you can do this on your own infrastructure. I actually use this on my own infrastructure. But we can do a bit better. And this is what we did as FreeIPA and SSSD teams together. And this is the second demo that I have. So this demo was recorded just this morning. I have to do it with my phone because, well, I have to look at the things that happen outside of laptop. You can see I'm basically asked it to connect the token, enter a PIN because it's protected by the PIN. Then touch the device, and I'm logged in. And now I have a Kerberos ticket to my home deployment. This Kerberos ticket is issued by my FreeIPA system hosted somewhere. It is very similar to how we integrated OAuth2 IdP. This is how it looks in FreeIPA web UI. You can assign different authentication methods to the user, and we call this passkey. Passkey here is what libfido2 supports, not the other.
Sorry, microphone. I need a microphone for this.
Yep. Yes, William has some ideas on it.
Yeah. So I actually work on and have contributed to the WebAuthn specification, and I write one of the major WebAuthn libraries for Rust. And there are no less than 4 definitions of what a passkey is, and all of them are different. And so depending on who you talk to, you will get a different definition. And so what Alex is saying is a passkey is any possible cryptographic authenticator. For some people, a passkey is an authenticator which is bound into your phone or your laptop. For some people, it is an authenticator which is synchronized via something like iCloud or Google. And for other people, it's a key which is backed by storage in the device. So depending on who you talk to, you will get a different answer, and all of these have a different range of consequences, from limiting to phones to bricking devices, which has actually already happened to some people. So you have to be very careful with that term.
Yeah, yeah. Unfortunate, but again, if we look at the mere users, the passkey seems to be a very good term.
It's a beautiful term.
To represent all of it. Yes.
So the thought leaders ruined it.
Yeah. And so again, this has two big parts. Well, actually, three big parts. There's a server side. There's a Kerberos integration, which is a pre-authentication method, which also has server and client sides. And then there is integration in SSSD itself, so that it knows which method to prefer to show to the user if passkeys are integrated with the user account and so on. So SSSD did a release last Friday, 2.9.0, which contains all this code. But it's mostly useless until you get the IPA side released. And IPA side is not yet integrated. We almost there. We needed the SSSD release first. Now we can submit all of this to IPA. There are a few things we want to fix in the LDAP storage of things before integrating, but mostly it works. So this is what I use on my laptop. I log into my FreeIPA deployment at home, get the ticket over KDC proxy, and then use that ticket to log in into VPN. Then I'm on home network. And the way it's kind of going similar to the previous diagram, I'm not going into details here, but on the right side where the FreeIPA server is, there are two blocks outside KDC, and these can be shared with Samba AD thing. The KDC side that allows us to share is MIT Kerberos, because it provides these pluggable pre-authentication mechanism. Heimdall also has them pluggable, but they are statically defined at compile time. You cannot redefine them at will, and you cannot install new ones, and so on. That would be good to kind of add this mechanism. The actual pre-authentication methods register it up in the IANA, so they are known now pre-authentication methods, so all Kerberos implementations theoretically can recognize them and work with them. So if we get to Samba AD, I kind of half answer it how we can integrate this. The prerequisite is obviously MIT Kerberos, right? There's a need to define a schema. We have some schema defined for storing these passkeys at least in Active Directory, LDAP, because we treat them similarly to SSH public keys. So if you store them in Active Directory, SSSD will see them and allow you to use a passkey to log in locally. You wouldn't get Kerberos ticket. And the reason, obviously, because Active Directory does not support Kerberos pre-authentication using this method. However, Samba AD with MIT Kerberos would be able to support this. Now the question is, what is the client, what we target here? Windows does not have this mechanism, so it would be useless to attempt to log in into Windows with this mechanism. Yeah?
Thank you. So are you really sure that Windows doesn't support something like that? Because they have Windows Hello and things like that.
I'm coming to that. Yes.
Okay.
It's a great audience that envisions the flow of talk. So Windows definitely doesn't have support to these Kerberos pre-authentication types. That's obvious. What Windows has is an integration, a generic integration, which is called NegoX. It's an extension of the negotiation exchange that if neither Kerberos nor NTLM SSP accepted or negotiated, a client and server can fall back to process anything else. And this is how integration with Azure, or when it started, it was live.com, right? Login, kind of online login for Office integrated. So there is a NegoX provider that effectively runs all this flow for login with online service, which is nowadays is Azure AD login.
Yeah, I mean, what I'm seeing in the schema definition and in the documentation is the MSDS key credential attribute, and there are some fields with names like FIDO2 and things like that, and they are also mentioned in the Kerberos documentation, and that's
But
why
they are not used. They are not using this method that we developed and registered. Yeah. So right one-to-one, it wouldn't work. They simply wouldn't negotiate the same set of pre-authentication methods. Windows client only will say, okay, I support password with encrypted timestamp, and that's all. Well, maybe a smart card, and smart card is the passwordless thing you have there, or could have now. If we introduce some NegoX plugin for Windows that supports this scheme, we could try to use something there, but we cannot have Kerberos as it is now. We need to do something else. We can discuss this with Microsoft, and it would be interesting to discuss these kind of extensions. There are a few more, like which I would like to have, like Spake. It improves security dramatically over this encrypted timestamp thing, but it's not there as well. So we can try. At this point, this all firmly to Linux desktops, and this is what we are kind of targeting. Again, on the desktop side, there are plenty of issues, and these issues known for years. The GDM in this login prompt is kind of very limited, dynamically inadequate. You cannot do really a lot of stuff there. We are discussing this with the GDM developers, and there is some promising progress across multiple companies. Some of canonical developers did a prototype to embed a browser into GNOME shell, and we hope to get that to the point where we can run it. Security-wise, we need to solve a lot of things, but we can run it in GDM at the login time. The other thing is that we're working right now with proof of concept, may be available in several weeks or so. We should get around this small input box where you see this message. We should get to be able to have a richer interface that adjusts depending on what you're using. If you're using external IDP login, you want to show this URL in a way that user can actually use it on the other device. So you want to show a QR code maybe that is scannable there. So this took probably 2 or 3 months to discuss and explain and get people to understand where it goes. For existing things for the like smart cards, we already have a mechanism inside GDM for like 4 years, since 2019, where GDM actually detects that if you inserted a smart card and you have multiple smart cards registered on you, then it shows you a special UI to choose which one you want to take, or it probes the smart card and pre-fills information about it. So that kind of thing already has, and we rely on similar methods there. And we want to have all of it improved. So I really hope by GUADEC in July we will have at least the user experience drafts together with the GNOME user experience people. And the most important part after this is if you're able to get Kerberos, then single sign-on should preserve across applications. If you are not able to get Kerberos, and you might not get because your directory service does not support the same authentication method, but is used just as a storage for presenting the passkeys, for example. We want users to be aware of it. We want to show notifications or leave warnings showing that your single sign-on experience will be limited because you don't have something. Please talk to your administrators and so on. So improving these small things is high on our agenda. It will take years. I'm not really optimistic in that like you get it tomorrow. No. But all this work started 2 years ago, so we gradually getting to where we've never been with this one. Then after you all got this, because there are so many moving parts, you need to integrate this in distribution. You just don't miraculously expect that this works just because we released it in upstream. So our current plan is to have the FIDO2 integration between SSSD, MIT, Kerberos, and FreeIPA to land in Fedora 39. It's on track, and the graphics improvements hopefully get somewhere around Fedora 40 or 41. So there are the majority of time spent on this goes into, hey, talking to different upstreams, talking to people, convincing them that this is a thing worth to include in your plans. Well, if not short terms, then at least mid-term things. And there are also multiple teams and multiple organizations working on bits and pieces of it. So there are, for example, groups of people working on portals for sharing the WebAuthn into the desktop, so that a browser does not have direct access to the tokens, but it asks for a service inside operating system, and that one can define, or user can define, which application, which browser can have access, can request this, or who cannot, and then use it in not only browsers, but in the other applications. There are certain security aspects that need to be worked out and figured out before we propose this to everyone as like, hey, go there. But I'm hopeful, and I'm really feeling that it wouldn't take 7 years. Yeah. So that's all the story I had to tell today. And if there are any other questions, please ask.